Hello everyone, my name is Gabby Cataloni and today I will be presenting my final project, the electronic piano. For my project, I constructed a small electronic piano using a 555 timer chip. This is interesting to me because my boyfriend loves music, and when brainstorming project ideas, I thought, how can I apply what I am learning in electronics to another discipline? My first idea was to connect LEDs to the piano keys, aka push buttons, so when you play a certain key, the corresponding light would flash. After a lot of trial and error with connecting the LEDs, which I will discuss more in detail later, I decided to make a different modification to my circuit. I decided to make the piano operational for people who are visually impaired by adding Braille to the push buttons. I believe this project idea is a fantastic way to connect different interests and reach a variety of people. When building the circuit, I utilized two key concepts that were discussed in class. The first concept is the use of frequency. When I think of a piano, the first characteristic I think of is the different sounds or tones it creates. These tones are equivalent to frequency values. Each key has a different note name that it represents, and the note name is equal to a certain frequency. To determine the frequency of each key created in the circuit, I used an app on my phone called Sound Detector. I pressed each key, recorded the given frequency values from the app, and used the frequency to determine the note name based off a piano frequency chart. I also calculated the frequency value based on the resistance values to compare the two values and find the percent error. The next concept I used was resistance. I used two legs of a potentiometer to control the resistance flowing through the circuit. When twisting the potentiometer, it changes the tones of the keys from very high to low frequencies based off the resistance in the circuit. As explained in the last slide, this is the app I use to measure frequency, which is in the top left. You can find it on the App Store for free. The equation I use to calculate frequency is in the bottom left. And the piano frequency chart I use to determine what frequencies belong to which note name is on the right-hand side. Since everyone watching this video has previously seen my other video, you will notice that the circuit diagram from the first video is very different from this one. That would be because when testing the circuit diagram I originally planned to use, I found out that a lot of the parts were connected incorrectly, and some of the values were way too large. Instead of finding another circuit online to base my idea off of, I decided to create my own circuit based on the 555 timer chip pinout diagram. And from the help of my parallel partner Jack, this was possible. The 555 timer chip is the main component in the circuit. The 555 timer performs like a continuously oscillating running oscillator, which changes between two unstable states. This means that the transistor inside the chip constantly switches from a cutoff to a saturation state. This state is determined by the RC circuit. Another important component of this design is the push buttons. When different buttons are pushed, different sounds are produced. This is because every time a button is pressed, a different value of resistance becomes connected in the circuit to generate different frequencies. As a result, we get different sounds from each button. The potentiometer is used to change the frequency of the piano to obtain higher and lower sounds/tones. The capacitors connected to the pin 1, 3, and 5 are used to charge and discharge the circuit so the chip is not damaged. Lastly, my circuit is connected to a 9-volt battery and the sound from the push buttons are outputted through the speaker. The first challenge I was faced with was using a circuit diagram that had many issues. For example, I started off using a 500K kilo-ohm potentiometer, which the circuit diagram suggested. But this value was way too high and produced screeching sounds when the keys were pressed, which obviously isn't ideal. Also, the circuit diagram did not have all the pins in the 555 timer chip connected in the circuit, which could potentially damage the circuit, and the chip. After realizing the circuit had many issues, I decided to create my own circuit based off a pinout diagram from the 555 timer chip. Another problem I encountered was connecting LEDs to the push buttons to create a circuit that lights up when the certain buttons are pressed. I connected these in many different ways, on and off, and every time I either shorted the push buttons or blew an LED. From this, I decided to put Braille on the keys, so it would be functional for a visually impaired user. I believe I met all these challenges with an open mind and solved them accordingly. Next, I will show you the demonstration of my circuit.
This is my demonstration of my working electronic piano. So right now the potentiometer is set on the lowest resistance value. So I'll play the keys. As you can see, on the keys is also the Braille for the key that it represents. So this first one is Braille for E. It's specifically E5, but I just did the Braille for the musical representation of the key. If I turn the potentiometer higher, you can hear the frequencies change.
Overall, this project can be very useful to those who are visually impaired. There are some products already created, like covers for your piano, if you are visually impaired and starting to learn the piano keys, but no one has created keys with Braille on them. This could potentially be improved with more research to create more accurate Braille patterns. What I mean by this is you could create more accurate Braille patterns by determining the number and letter value in Braille. I'm not sure if this has already been created or if this still needs to become created. There are a lot of different ways that Braille has been adapted and changed to fit in within different music instruments, such as the harp, like I said before, covers on piano keys. Another example would be the musical notes for like a clarinet. They also have an idea that they're presenting right now where you can feel Braille with like your left hand and play with your right. But if you had the Braille on the keys, you could use both keys to play both hands to play the piano, so one hand wouldn't be taken away by having to read the notes on the screen. Thank you all for watching my final presentation, and good luck with the rest of the semester.